Welcome to Chapter 5, Multiplication and Division. Now you may be looking at this and thinking, we did this back in grade 3. Or you might have just came to our program and you weren't here for grade 3, so you didn't learn this. Because most schools learn multiplication and division in grade 4. But not us, we learn it in grade 3. Worry not though, because we are going to go over this again. Now relate multiplication and division. Multiplication and division are opposite operations, which means that if you multiply something, then the same fact also applies during division. Such as use a related fact to find 15 divided by 5. How many groups of 5 are in 15? 3 groups of 5 are in 15. 3 times 5 equals to 15. Therefore, 15 divided by 5 is 3. Now we see here, 21 divided by 7. 7 times 3 equals to 21. Therefore, 21 divided by 7 equals to 3. But, well, us over here, we're not going to use these diagrams. Because guess what? If you're using diagrams and stuff for multiplication, you're not going to survive grade 9 math. You're just not. Let alone grade 10 math. And grade 11 math. Because those are mandatory courses. This is what you should remember. Your multiplication tables. Now, I know that in English it's tedious. 1 times 1 equals to 1. 1 times 2 equals to 2. 2 times 2 equals to 4. Stuff like that. But in a lot of Asian countries and non-English countries, they just do... They literally have this entire chant for this type of stuff. Which makes it much easier to remember. But guess what? You're going to have to remember it either way. So just cram this into your head somehow. Like, take it and shove it in your brain. I don't care how, just shove it in your brain. Now, 27 divided by 3. Well, you go to the 3 column and you see 3 times what equals to 27? 3 times 9 equals to 27, so 27 divided by 3 equals to 9. Now we have 36 divided by 9. We look at everything with 9, and then we see 9 times what, or what times 9 equals to 36. And we get 4 times 9 equals to 36. So 36 divided by 9 equals to 4. The last question, 40 divided by 8. Well, we go to the 8 column and row. And we see what times 8 equals to 40. We get 5 times 8 equals to 40. So 40 divided by 8 equals to 5. That's it for section 1. Now we move on to section 2, which is talking about multiplication and division properties, such as the commutative property. Remember the commutative property for addition? It applies to subtraction too. So basically, the order of the factors does not change the answer. 3 times 6 and 6 times 3 both equal to 18. If you want a visual, then 6 times 3, 3 groups of 6, and 3 times 6, 6 groups of 3, they're equal. They both equal to 18. Now there's also the identity property, which is slightly different. Because in addition, the identity property was anything add 0 equals to, well, that thing. In multiplication and division, well, we're just talking about multiplication right now. It's anything times 1. So 3 times 1 equals to 3, 7 times 1 equals to 7. Think about it. You have a box of 7 pizza pockets. If you have one box of 7 pizza pockets, you have 7 pizza pockets. If you have one box of 12 crayons, you have 12 crayons. The 0 property is the product of any number and 0 is 0. 0 times 4 equals to 0. 0 times 6 equals to 0. 6 times 0 equals to 0. It's like saying, I don't have a box of 6 cookies. Then that just means that you have no cookies. Now we're just going to identify the properties shown by each number sentence. 6 times 4 equals to 4 times 6. You switch around the order, which means that this is the commutative property. Seven divided by 7 equals to 1. This corresponds to the fact that 7 times 1 equals to 7, which means that this is the identity property. Give yourself enough space when you're actually writing this, guys. 0 times 6 equals to 0. 0 times anything equals to 0. That's the 0 property. 0 divided by 8 equals to 0. This corresponds to the multiplication fact that 8 times 0 equals to 0, which means that this is also the 0 property. Two divided by 1 equals to 2. This corresponds to the fact that 2 times 1 equals to 2. Therefore, this is the identity property. Three times 1 equals to 1 times 3. I know this might look like the identity property, but this is showing that the order doesn't matter, which means that this is a commutative property. Complete each number sentence. 8 divided by 8. Anything divided by itself is equal to 1. 9 times 6 equals to something times 9. The order doesn't matter, so 9 times 6 equals to 6 times 9. 3 divided by 1. 1 times anything equals to itself, therefore 3, well, divided by 1 equals to 3. Anything divided by 1 equals to that thing. 0 divided by 7. 0 divided by anything is just 0. However, if you divide anything by 0, it's undefined. Like, there is physically no answer for this. Well, anything. Let's just put Q. Yeah, that's a rule, by the way. 2 divided by something equals to 1. Anything divided by itself equals to 1. 2 divided by 2 equals to 1. 8 times 1, identity property of multiplication, equals to 8. We move on to the third section. Multiplication and division facts through 5. You can double a fact you know to multiply 4 and 8. So here's how you would double a fact. You would say that 4 times 8 equals to 2 times 8 plus 2 times 8. Don't do this. Don't do this. At least not for small numbers. Anything under 10, well actually anything under 12 is a small number. Like single digit multiplication and single double digit multiplication, like by single double digit I mean say 2 times 11. Don't do this. Because guess what? If you do this, if you actually need to do this right now, first of all, you need to remember your multiplication table. Second of all, you're not going to survive high school. So you better remember that multiplication table, guys. Please. Okay, I'm not saying that this idea is completely stupid. Because if you have something like 14 times 28, and you're like, oh dear, I don't want to get a piece of paper and I don't have a calculator. What do I do? Well, I know that 14 times 28 equals to 14 times 14 plus 14 times 14. Now, all of you might be looking at me confused, going like, this teacher's crazy. What is 14 times 14? How do you know that 14 times 14 equals to, well, how do you know what it is? Well, guess what? By the time you're a certain age and you've done enough math problems, you remember what 14 times 14 is. So 14 times 14 plus 14 times 14 equals to 196 plus 196, which is equal to 392. Yeah. The effects of too much math on the brain. Anyhow, find 30 divided by 5. Think how many groups of 5 are in 30. Don't just look at your multiplication table. Actually, no, don't even look at your multiplication table. Remember your multiplication table. Just recall the multiplication table from the depths of the recesses of your brain in some crevices or another and obtain that 5 times 6 equals to 30. Therefore, 30 divided by 5 equals to 6. Yeah. Anyhow, we're going to double ones to show you how it works. So 6 times 4 equals to 6 times 2 plus 6 times 2 equals to 12 plus 12 equals to 24. But, well, guess what, guys? 4 times 6 equals to 24. It's right on your multiplication table. You have to remember your multiplication table, guys. Because guess what? Your multiplication table is, I'm sorry to tell you this, but one of the basics of math. Like one of the basic building blocks of math. What math stands upon is your multiplication table. Well, and addition and subtraction and division, but your multiplication table is extremely important. So please, do yourself a favor, and do your teacher a favor, and do your calculator a favor, and do your brain a favor, because it needs exercise. And remember your multiplication table. Now, 7 times 8. 7 times 8 equals to what? Hint, 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 hint. Hint, hint. 56. 4 times 3. 4 times 3 equals to what? Hint, hint. Hint, hint. 12. The next question is 6 times 9. 6 times 9 equals to what? Hint, hint. 54. Now, I recommend that you go online and find a multiplication table and print it out. Or you can use this one. And remember it. You have to remember your multiplication table. Don't be lazy, because guess what? A bit of laziness right now will cost you so much in your later life. You have to take math until you have to take math in grade 11 too. So, guess what, guys? You're in grade 4. You have another 7 years ahead of you. If you want to survive those 7 years, remember your multiplication table, please. Well, it's not the only thing that you have to do to survive those 7 years, but it's one of the big things that you do have to do. Draw models if you wish. Don't. It's not going to help you. Well, it might help you, but try to avoid drawing models in grade 4. Just try to avoid it. Your mind's going to get used to it. You're not going to have the space to do that in grade 9 or 10. And then you're just going to stare at the teacher going like, what is she or he saying? And then be all confused because, well, guess what? You have to get the basics down really solid. Yay! Math! 15 divided by 3. You remember your multiplication table. You reach into the deep pocket of your brain. And then you go like, aha! And you see that 3 times 5 equals to 15. Therefore, 15 divided by 3 equals to 5. 30 divided by 5. You reach into the recesses of your mind again and you pull out your multiplication table from your mind and you get 5 times 6 equals to 30. Therefore, 30 divided by 5 equals to 6. Oh, I'm doing this way when you're supposed to do it this way, but hey, as long as you get all the questions done, it doesn't really matter which order you do them in. Unless you have to complete one question to get to the other question, then you might have a problem, but you don't. 32 divided by 4. You sit down and peruse what you have once learned and seen, and you get that 4 times 8 equals to 32, which means that 32 divided by 4 equals to 8. 27 divided by 3. You continue your sitting down and continue to peruse, and you get that 3 times 9 equals to 27. So 27 divided by 3 equals to 9. 16 divided by 2. You suddenly remember that 2 times 8 equals to 16, which means that 16 divided by 2 equals to 8. 8 divided by 2. If you have to draw a model for this, you are in serious trouble, my young friend. But remember your multiplication table. 2 times 4 equals to 8. Therefore, 8 divided by 2 equals to 4. Wow! That's that section done. So we're going to move on to a problem-solving skill. If you want to take a break at any time during the video, feel free to do so. Choose an operation. Nadia collects souvenir flags. Souvenir flags? Okay, I prefer souvenir coins, but to each their own. She puts the flags in her bookcase. Bookcase? You mean bookshelf? The flags take up 3 rows. Oh, that's a lot. There are 7 flags in each row. Oh, that's not as much as I thought. How many flags does Nadia have? So what do we know? We know that there's 3 rows of 7 flags. What do we need to find? What that means. 3 rows of 7 flags means, i.e. how many flags there are. Choose an operation. 3 rows of 7 sounds awfully like those models that you use for multiplication. Eyebrow, eyebrow. 3 times 7 equals to, that's a 7, guys. 21. She has 21 flags. Look back at the problem. Nadia collects souvenir flags. She puts the flags in her bookcase. The flags take up 3 rows. There are 7 flags in each row. How many flags does Nadia have? 3 times 7. Our flags are correct. Get it, guys? Instead of facts, it's flags. Okay, our facts are correct. Therefore, our answer should be fine. We're going to do some practice problems. Mitch has 529 soccer cards. Ben has 287 soccer cards. How many more soccer cards does Mitch have than Ben? So it asks for how many more. Usually this means subtraction. That'd be, and then 9 minus 7. He has 342 more cards. Dean buys 6 packs of hockey cards. There are 6 hockey cards in each pack. How many hockey cards does Dean buy? Therefore, well, we get 6 packs of hockey cards and 6 hockey cards in each pack. So that's 6 times 6, which is equal to 36. He bought 36 cards. Jenny puts photos of her puppy in a photo album. The photo album can hold 250 photos. Jenny has 138 photos. That's a lot of photos of your puppy. How many more photos can she put in the album? Well, how many more, which is subtraction again. That would be, she can put 112 more photos. Abdullah has 4 rows of sock pairs in his drawer. Wow, he actually has his socks in rows. A lot of us just have a sock drawer and everything's just piled in there. Anyhow, each row has 8 pairs. How many pairs does he have in all? Wow. A certain number of things in rows? That sounds suspiciously like multiplication. 4 times 8 equals to 32. He has 32 pairs of socks. Liu Ying puts her comic books into 3 airtight bins. If each bin holds 18 comic books, how many comic books does she have? That's 3 times 18, which is equal to 54. 54 comics. Well, comic books. She has 54 comic books. Marilyn has 13 apples. If she gives none of them away, wow, how many does she have left? 13 minus 0 equals to 13. She has 13 apples left. Unless she ate some of them. Okay, ignoring that. If you want to take a break at any time during the video, feel free to do so. Multiply and divide facts through 10. Multiply. You can skip count with nickels to multiply 5. Don't. Just don't. Remember your multiplication table, children. Remember. Find 6 times 5. 6 times 5 equals to 30 because of your multiplication table. If you do skip count though, you get 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5. Yeah. Find 72 divided by 8. Remember that good old multiplication table? 8 times 9 equals to 72. Oh yeah! Fun trick. Put up your fingers and 9 times 1 equals to 9. 9 times 2, put down your second finger, equals to 18. 9 times 3 equals to 2, 7, 27. 9 times 4 equals to 3, 6, 36. 9 times 5 equals to 4, 5, 45. 9 times 6, guys, this is hard. Keeping your fingers down like this is harder than it looks, okay? Equals to 5, 4, 54. 9 times 7 equals to 6, 3, 63. 9 times 8 equals to 7, 2, 72. 9 times 9 equals to 8, 1, 81. 9 times 10 equals to 9, 0, 90. Cool trick, right? Now, multiply or divide. 8 times 6, you pull out that multiplication table from either your mind or if you haven't remembered it yet, somewhere else. I don't know, your desk, under your desk, a drawer, bookshelf, anyhow. And you get that 8 times 6 equals to 48. 25 divided by 5. 5 times 5 equals to 25. Therefore, 25 divided by 5 equals to 5. 40 divided by 8. 8 times 5 equals to 40. Therefore, 40 divided by 8 equals to 5. 7 times 8. 7 times 8 equals to 56. 63 divided by 9. You remember that 7 times 9 equals to 63. So 63 divided by 9 equals to 7. 21 divided by 7. 7 times 3 equals to 21. 21 divided by 7 equals to 3. 9 times 9 equals to 81. 30 divided by 6, well, 6 times 5 equals to 30, so 30 divided by 6 equals to 5. 36 divided by 4, 4 times 9 equals to 36, so 36 divided by 4 equals to 9. 6 times 9 equals to 54. 7 times 6 equals to 42. And 5 times 7 equals to 35. So, we're going to do some multiplication with 11 and 12. You can use a related multiplication fact to find the quotient to a division problem, but you could just use multiplication. Elvis, and 6 of his friends go to the amusement park. The total for all of their tickets was $84. How much did each person pay for his ticket? So that's 7 people. We could do a vertical division or a long division, and we get 8 divided by 7 equals to 1, and then $12. Here's the thing. For 12, the multiplication is slightly more difficult to remember. But for 11, it's just, say, 3 times 11 is like, just 33. 4 times 11 would be 44. 5 times 11, 55. 6 times 11, 66. 7 times 11, 77. You get the idea. Up until 10 times 11, and then it would become 110. And then 11 times 11 equals to 121. 12 times 11 equals to 132. At the store, how many dozen muffins are in a tray of 72? Find out how many dozens of muffins are in 72 by finding what times 12 equals to 72. We're not going to skip count by 12s. Okay guys, the thing is, in a baker's dozen, there's 13, but over here they're obviously not talking about a baker's dozen, so we won't concern ourselves with that. But let me tell you something. After a few years of math, you start remembering that 5 times 12 equals to 60. Yeah, 6 times 12 equals to 72. If you want to do it vertically, you would get 72 and 12. And eventually you'll end up with 6. Now we're going to do some multiplication and division with 12s. 12 times 9. Well, 12s and 11s actually for this. 9 times 2, 18. Regroup. And then 9 times 1, 9. Add on the regrouped 1, you get 10. You have nothing to regroup the 1 to for the 10. So you just drag it down and you get 108. Then it's 99 divided by 11. As I have said before, well, 99 divided by 11 is actually just 9. Because if you think about it, 9 times 1, 9. 9 times 1, 9. Yeah, we're going down. Never mind. 11 times 12 equals to 1 times 2, 1 times 1, 1 times 2, 1 times 1. $132. We go back to 11 times 11. By the time you get to a certain grade, you just remember that this is 121. Multiplication is really just a bunch of memorization. There's not that many techniques to go by. It's a little bit like addition. Like addition, you have to remember what 8 times 8 is. That's multiplication, except multiplication is a little bit bigger and longer, and yeah. Oh! 108 divided by 12. 12 times 9 equals to 108. Well then, equals to 9. 12 times 5, again, 12 times 5, you get to a certain grade, you remember that it's 60. But 5 times 2, 10, you regroup the 1. 5 times 1 plus regrouped 1, 6, 60. Yeah, let's just get that out of there. Because if I remember correctly, there is a symbol that's an equal sign with a dot on top of it, and it does not mean what equals, so it doesn't mean the same thing. Therefore, we're not going to use it. Question number 7. Art students were making frames out of craft sticks. Okay then. Each frame uses 12 sticks. If there are 144 total sticks, how many frames can they make? 144 divided by 12. I already know the answer, but you do the vertical division, you get this. 2 12s fit into 24. And then you end up with, they can make 12 frames. Problem-solving investigation. To practice making sharper turns, Lyra sets up an obstacle course. She places cones 6 feet apart over a distance of 42 feet. She places the first cone 6 feet from the starting line. How many cones does Lyra use? Be sure you understand the problem. Read carefully. What do we know? Well, we know that it's cones 6 foot apart over 42 feet. First cone is 6 feet from the starting line. How many cones does Lyra use? Is what we need to find. For our plan, we could use math, algebra, or we could draw a picture. Well, diagram. So the diagram will look something like this. And we would count starting from 0 by 6s. 18, 24, 30, 36. Oh, well, the spacing isn't exactly even, but you get the idea. 42. We got to 42. And that would be 1, 2, 3, 4, 5, 6, 7. 7 cones. We could also write an equation. 42 divided by 6 equals to 7 cones. However, you will hear me saying this once, and you will hear me say this again. Well, in questions like these, if she does place a cone at the starting line, then it would be total distance divided by distance between each thing. It might be a cone, it might be a bush, plus 1 equals the total number of things. However, if she doesn't place one at the starting line, or she places one at the starting line but doesn't place one at the finishing line, then you wouldn't have the plus 1. But if she doesn't place one at the starting line and she doesn't place one at the finishing line, then you would have to put minus 1. It's a bit similar to this. This diagram right here. There's 2 spaces. There's 1 line dividing the spaces. But if you count the 2 lines over here, then that would be 3 vertical lines in total. Math is strange sometimes. Is the solution reasonable? I mean, yeah, it seems reasonable. Reread the problem. Does your answer make sense? And is your solution reasonable? It's kind of the same thing. But then again, in math, you could have some really strange answers. Like, the person can buy 300 bottles of soda at the supermarket. People don't usually do that. And by bottles, I mean 2-liter bottles. Yeah, that's about the right size. Which method do we prefer? Well, that's personal preference. But honestly, the algebraic method is much less line drawing-ish. And usually you might not have enough space to draw a line, and for the most part, If you know your multiplication table, the algebraic method would be really easy. And if you don't know your multiplication table, please know it fast. So we reread the problem to make sure our facts are correct. Lyra sets up an obstacle course. She places cones 6 feet apart over a distance of 42 feet. She places the first cone 6 feet from the starting line. How many cones does Lyra use? Yeah, we also answered the problem. So, that's it. Okay, practice problems. The Parks Department builds 8 rows of stands next to a baseball field. Each row is 70 feet long. How many 10-foot long boards do they need to build the stands? Well, 70 divided by 10 equals to 7, which is the amount of boards they need for each row. And then there's 8 rows, so 8 times 7 equals to 56. They need 56 boards. This is much quicker than drawing a diagram. Ed has 8 packs of sports stickers. There are 36 stickers in each pack. He divides the stickers among 4 friends. How many stickers does each friend get? So there's 8 packs of sports stickers with 36 stickers in each pack. And we get 288 stickers. Now, assuming that Ed himself doesn't get any stickers because 288 is not divisible by 5, 288 divided by 4 equals to 72. Assuming Ed does not take any stickers, each friend will get 72 stickers. Well, now that that's done, we move on to section number 8. Multiply 3 numbers. You can use the associative property of multiplication to multiply more than 2 numbers. It's a bit like the associative property of addition. For example, you have 3 cats and they each eat 3 cans of food per day. How many cans do they eat in 1 week? So basically it's 3 times 3 times 7. And you get 3 times 3 in brackets times 7, which is equal to 9 times 7, which is something that we know from, well, our multiplication table. 9 times 7 equals to 63. So let's do some practice problems. Multiply. 3 times 4 times 10 can equal to 3 times 4 times 10, which is 12 times 10, which is equal to 120. That's an equal sign, by the way. I'm going downwards, okay. 11 times 5 times 2 is equal to 11 times 5 times 2 in brackets is equal to 11 times 10, and 11 times 10 is equal to 110. Now we have 8 times 1 times 4. But the identity property says that if you times anything by 1, you just get the same thing. So technically, this is equal to 8 times 4, which is equal to 32. Now we go back, and we get to 6 times 2 times 3, which is equal to 6 times 2 times 3 in brackets, which is then equal to 6 times 6, which is equal to 36. 2 times 9 times 5 is equal to 2 times 5 in brackets times 9 due to both the commutative and the associative property of multiplication, which is then equal to 10 times 9, which is equal to 90. Nine times 4 times 3 is equal to 9 times 4 times 3 in brackets, which is equal to 9 times 12, which is then equal to, if you remember from way back when, a few sections ago, 9 times 12 is equal to 108, but there we go. Copy and complete each number sentence. We don't really need to copy right now, so okay. 6 times something times 2 equals to 48, which means that something times 6 times 2, which is 12, equals to 48. 4 times 12 equals to 48, so the something is 4. 8 times 9 times something equals to 72. 8 times 9 equals to 72 times something equals to 72. So according to the identity property of multiplication, 72 times 1 equals to 72. 7 times 2 times 3 equals to 7 times 2 times 3, which is equal to 7 times 6, which is equal to 42. 2 times something times 4 equals to 96. 2 times 4 equals to 8, so something times 8 equals to 96. 96 divided by 8 equals to 12. Therefore, 12 times 8 equals to 96. The missing number is 12. Wow! If you want to take a break at any time during the video, feel free to do so. Section 9, Factors and Multiples. Laura is arranging her photos. She has 10 photos to arrange in a frame. How many ways can we arrange them? So a factor is a number that divides into another number that results in a whole number. So think about it. The factors of 10 include 10 divided by 10 equals to 1, 10 divided by 1 equals to 10, 10 divided by 2 equals to 5, and 10 divided by 5 equals to 2. Remember guys, it has to be whole numbers. That's it for the factors of 10. So the factors of 10 are 1, 2, 5, 10. It's good to list them from least to greatest. Which means that the ways that Laura can arrange her photos is 1 by 10 or 2 by 5. Now what is a multiple? So a multiple is, well, you take a number and then you multiply it by something, and that means that the product that you get is a multiple of both of these numbers. Say C equals to A times B. C is a multiple of A and B. That's an A, guys. Find the first 7 multiples of 4. We have 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. 4 times 5, 20. 4 times 6, 24. 4 times 7, 28. Voila! First 7 multiples of 4. Now we're going to do some exercises. Find all the factors of each number. 19. 19 has only 2 factors. 1 and 19. How do I know this? It's not divisible by any others. 19 divided by 2, you're not going to get a whole number. 19 divided by 3, you're not going to get a whole number. 19 divided by 4, you're still not going to get a whole number. 19 divided by 5, you're not getting a whole number here. 19 divided by 6, nope. 19 divided by 7, nope. 19 divided by 8, nope. 19 divided by 9, nope. 19 divided by 10, nope. And we're already over half, so it's there's no point in going any further. 28. 28 can be divisible by 1, 2. Okay, guys, here's how I like to factor. 1, 28. 2, 14. 4, 7. You just go up in a pyramid. And you get 1, 2, 4, 7, 14, 28. For 6, it would be 1, 6, 2, 3. 1, 2, 3, 6 are the factors of 6. We move on to multiples. Identify the first 5 multiples for each number. 7. 7 is a multiple of 7. 7 times 2, 14. 7 times 3, 21. 7 times 4, 28. 7 times 5, 35. 7 times... Oh, never mind, it's first 5. We don't need to continue anymore. 3. 3 times 1 is 3. 3 times 2, 6. 3 times 3, 9. 3 times 4, 12. 3 times 5, 15. First 5 multiples of 3 right there. 8. 8. 8 times 1, 8. 8 times 2, 16. 8 times 3, 24. 8 times 4, 32. 8 times 5, 40. First 5 multiples of 8. We move on to the last section of the chapter, but it's not time to slack off yet. Allison is organizing her shoes in a shoe rack. There are the same number of shoes in each row and column. If Allison has 24 pairs of shoes, how many ways can she arrange her shoes? You need to find all the factors of 24 to find out how many ways Allison can arrange her shoes. Oh god, there's a lot. 1, 24, 2, 12, 3, 8, 4, 6. Yeah, that's it. So she can arrange it 4 by 6, 3 by 8, 2 by 12, and 1 by 24. You get why I like it so much now? You get everything in order and everything in pairs. Nice, right? So what's a composite number? A composite number would be something like 24. You have factors other than 1 and 24. Numbers with factors other than 1 and itself. So what's a prime number? Numbers with only 2 2 factors. 1 and itself. Such as 19 in the last section. Now we're going to do some factoring. Find the factors of each number, then tell whether the number is composite or prime. 12. We have 1, 12, 2, 6, 3, 4. Now that's definitely factors other than 1 in itself, so it's composite. 9. 9 has 1, 9, and 3, but 3 and 3 are the same number, so it's just 3. But that's still something other than 1 and itself. Therefore, 9 is also composite. 23, on the other hand, has 1, 23. That's it. How do I know this? Because by the time you reach a certain level, you start remembering prime numbers. Like all the prime numbers under 50, you'd probably be able to identify them on sight. $35 has 1, 35, 5, and 7, which is more than 1 in itself. Now we have the last question, but not time to slack off yet, kids. Solve. Arrange a bulletin board with equal rows and equal columns for 60 drawings. Oh god. 60 has a lot of factors. A lot of factors. I'm just going to put that out here. 60, 2, 3, 20, 4, 15, 5, 12, 6, 10. Any more. Nope. So you can arrange the bulletin board 6 by 10, 5 by 12, 4 by 15, 3 by 20, 2 by 30, and last but not least, well actually no, it is kind of the least because this is an extremely badly designed bulletin board. 1 by 60. When it's a picture frame or any frame and it's something by something, you use the times symbol or multiplication symbol. And that's the end of the chapter, guys. I'll see you next chapter.